Hello friends, I am Professor Dattu Patel from LJ Institute of Engineering and Technology. Earlier lecture, we already studied about ordinary point, regular singular point, irregular singular point and examples of discussed singularity. Today's lecture, we study about series solution about an ordinary point by power series method. Basically, we find series solution about x0 if x0 is a ordinary point, then we find series solution by power series method. And if x0 is a RSP, means regular singular point, then we find a series solution by Frobenius method. Today we learn about power series method. Let us start with one example. Find series solution of y double dash plus x square y equal to 0 about x0 equal to 0. First, whatever the differential equation which is given in question, that is your equation number 1. Then y double dash plus x square y equal to 0, that is our equation number 1. Now, whatever the coefficient which is multiplied with y double dash, that is indicated by P of x0 equal to 1, which is not equal to 0 at x0 equal to 0. Then we can say that x0 equal to 0 is an ordinary point. Clear? Now, let y equal to summation k equal to 0 to infinite ak x raised to k is the series solution of given equation. Now, differentiating y with respect to x twice, then y dash equal to summation k equal to 1 to infinite ak k x raised to k minus 1. Again differentiate, then we get y double dash summation k equal to 2 to infinite ak k minus 1 x raised to k minus 2. Now, substitute the y double dash and y in equation 1. We get summation k equal to infinite ak k minus 1 x raised to k minus 2 plus x square summation k equal to 0 to infinite ak x raised to k equal to 0. Now, this x square goes inside the summation. Then x raised to k into x square means base is same. Then power will be added. Then x raised to k plus 2. It's become x raised to k plus 2. Then summation k equal to 2 to infinite k minus 1 x raised to k minus 2 plus summation k equal to 0 to infinite x raised to k plus 2 equal to 0. Now in first term power of x is k minus 2 and second term power of k is k plus 2. To make highest power of x, with the help of replace the value of k. Then in first term replace k as a k plus 4 to make x raised to power k plus 2. Then we get summation k equal to minus 2 to infinite k plus 4 k plus 3 and x raised to k plus 2. Second term which is as it is. Only first term which is replaced as a k plus 4. Now in this equation first term has a summation index is minus 2 and second term has a summation index is 0. Then to make same summation index in both terms, here highest summation index is 0. Then put the values of k equal to minus 2 and minus 1 in first term. Then we get, first put the value of k equal to minus 2 in first term. Then we get a2, 2 into 1, x raised to 0. Plus put the values of minus 1. Then we get a3, 3 into 2, x raised to 1. Plus remaining term k equal to 0 to infinite, k plus 4, k plus 4, k plus 3 and x raised to k plus 2 plus second term which is kept same as ak x raised to k equal to 0. Now equate the coefficient of coefficients of various powers of x with 0. Then we get first term which is 2a2 equal to 0. Then we get a2 equal to 0. Similarly second term 3 2s are 6, a3 equal to 0. Then we get a3 equal to 0. Now another equation is ak plus 4, k plus 4, k plus 3 plus ak equal to 0 now. Do the subject as a ak plus 4. Then ak plus 4 equal to ak goes that side, then minus ak, then k plus 4, k plus 3, where k greater than equal to 0. This equation recurrence means relation. Substitute k equal to 0, 1, 2, 3, etc. and we get A2, A3, A4, A5 and so on in terms of A0 and A1. First, put the value of k equal to 0 in recurrence relation. Then k equal to 0. Then we get A4 minus A0 divided by 4 into 3, which is minus A0 divided by 12. Then k equal to 1. Then we get A5 minus A1 divided by 5 into 4, which is minus A1 divided by 20. K equal to 2, which is A6. Then put the value of 2, then A2 upon 6 into 5. But value of A2 is 0. Then k equal to 3, which is A7. Then minus A3, 7 into 6. But the value of A3 is 0. Then k equal to 4. Then we get A8. Then minus A4 divided by 8 into 7. Now minus 1 upon 8 into 7 as it is. Put the value of A4 is minus A0 divided by 4 into 3. Then minus minus plus. Multiply this term 8 into 7 into 4 into 3. Then we get 672, which is A8. Now put the value of k equal to 5. Then we get A9 equal to minus A5 upon minus A5 upon 9 into 8. Then put the values of 9 into 8, minus 9, then minus A1 into 5 into 4. Multiply this term, then we get A1 divided by 1440, that is value of A9, and so on. Now put these values of AKs in equation number 2. Put the values of A1, A2, A3 and so on in equation 2, which is y equal to A0 plus A1x plus A2x square plus A3x cube plus A4x raised to 4 plus A5x raised to 5 and so on. First y, A0 as it is, A1x as it is, A2 which is 0, A3 which is also 0, then A4 which is minus A0 by 12 x raised to 4 plus A5 which is minus A1 by 20 x raised to 5, A6 0, A7 which is also 0, A8 which is A0 divided by 672 x raised to 8 plus A9 which is A1 divided by 1440 x raised to 9 and so on. Now in this equation a0 common, then first one is 1 minus x raised to 4 by 12 plus x raised to 8 divided by 672 minus and so on plus a1 first term which is x minus x raised to 5 by 20 plus x raised to 9 divided by 1440 minus and so on, which is equation number 8, where a0 and a1 are arbitrary constants. This equation, this is required solution of given differential equations. In this example, question which is second order differential equation, then solution has two arbitrary constant. If question has single order differential equation, then we get only one arbitrary constant. Similarly, you can solve following examples as a tutorials. Then y double dash plus xy equal to 0 about x0 equal to 0. First one. Second one, y double dash plus y equal to 0 about x0 equal to 0. Third one, y double dash equal to 2y dash about x0 equal to 0. As a homework, you can try these sums. If you have any doubts, then feel free contact me. Thank you so much.